We're going to cover 3 topics. First, the different attack vectors. Second, we're going to talk about the frameworks we're going to use to attack. We're not going to talk about that a lot. Then the most part, we're going to write some malware. We're going to use how we use it and what we're going to do and how to defend about it. That's basically what we're going to do in these 40 minutes. So first thing is credential stuffing. So how many people duplicate their passwords? I mean, how many people use the same password for the same site for the same stuff? So, and how many use the name of their dogs for the password, or the name of their pets, or the name of their birthday? So, obviously, it starts with a breach or with a combo list where you have a large amount of usernames and passwords that were once used to one site that was breached. And then the part of credential stuffing is that an attacker would take that big database and just try it out. You know, go to that site, go to that site, go to that site, try that, try that, try that, try that, try that, try that, try that. That's credential stuffing. So, and then some of it works, some of it doesn't, but some of it lucks out because you have used the same user and the same password for different sites. And then once you have that, you can either use that or you can take that piece of information, which I have that username and that password working with that site, and just sell it to someone else and get some Bitcoin for that. And he'll exploit that for you. You don't have to do the hard work for it. So you start, okay, how do I get this big combo list? That's the easy part. You know, you just go into Telegram, you say, I want combo lists, you get it. You know, if you want to get a good combo list, you put some Bitcoin down, you get good combo lists. You want to see how you get combo tools, how you take that list and you script them out, that's easy as well. That's not the hard part. You get that, you get money. That's the interesting part. And obviously, you can get like the username and passwords from human intelligence and from other stuff, but we're not going to talk about that. That's the easy part. Then we have, once you have this combo list, you have 2 different type of ways to attack. One of them is centralized credential stuffing. That means that you're in control of the devices. You have one device farm, you have a bunch of emulators, you have a bunch of scripts doing CURLs or Python scripts, and you're attacking backends. You're trying to send stuffing, trying to send usernames and passwords to all these sites. And that's easy for you, for the attacker. You got direct control, nobody's blocking you, you can do whatever you want, it's your own site. Hard part is the backend. The backend is against that. I mean, the backend says, I don't want a lot of requests from the same IP, I don't want a lot of requests in the same second, I want some authentication, I want anti-bot stuff. So we can do a big session about that, but defense there is in the backend. It's in the WAF, it's in the web application firewall, it's in front of the DB. We're not going to talk about that. The second part is decentralized credential stuffing. Decentralized credential stuffing means you have a big botnet. You have a lot of apps in real users' hands. They're real users, they're real use cases. You don't need to worry about the authenticity. You don't need to worry about that. It's actual phones of actual users, actual sessions. You're bypassing all the anti-bots. You're bypassing all the backend checks because you're actually sending it from real devices. Hard part, you got to infect all these devices and start weaponizing them. That's the hard part. So that's what we're going to talk about today. The protection from there is going to be on the mobile side, obviously, because the backend is unaware. And then let's talk about another attack vector. It's a bit more sophisticated. It's called ADS. ADS is automated transfer systems. I want to show you a short movie about how it looks. Then we're going to see exactly what's behind it. So this is a banking app in Brazil, and we're going to see it. He's going to basically transfer money to his friend. 1 second. He's going to choose who he wants to send to. He's going to send a contact. He's going to send 1 real to his friend. Yeah, he's going to confirm it. Yes, I want to send 1 real to my friend. And then he's going to verify it. Yes, I'm sending 1 real to my friend. And now, when he's going to press next, moving into the 2FA when he needs to approve the SMS, now you can look at the bottom, you see a small flicker. It's very hard to notice. You see it just now? Like a small flicker in the bottom while the spinner is happening. So it's almost unnoticeable. And then that's the 2FA. Now he's going to move back, and you're going to see that it's a different amount of money to a different person. So that's what happened in the background. Had he approved the 2FA, he would have sent not 1 real, but 600 reals, and not to who he wanted to, but to someone else. So that's a real video of a real attack. And we're going to break that down a bit, what we just saw, on how it's related. So basically, that's called ATS, Automatic Transfer Systems. It has the ability to hijack the transfer systems and then send money to one place instead to the other place. What we just saw is a Trojan called Brastex. It's widespread around Latin America, but we have a lot of other stuff. We have Xenomorph, we have Flubot, Sharkbot, Pixabot. We have like, I don't know, 7, 8, 10 different variants of this sense, each of them specifically targeting applications. You have to go and understand the flow of the app, mimic the app, understand exactly what you're doing, but they keep just adding to it, and we've seen over 500, 600 different apps being attacked, and about tens of thousands of users being affected by this. So it's a real epidemic in that sense, and it's worthwhile because you do get money very fast. Like you actually transfer money to yourself. Xenomorph is the big one around UK, attacking banks and financial institutions around UK, Spain, Italy, Belgium. But we have other variants all over the world, and they basically use the same idea. Basically, what they do is first you infect the device with a Trojan. That happens through social engineering, through downloading apps that are cracked from outside the Play Store, through apps that get put into the Play Store, but their DEXs are encrypted, and they pass all these checks. You can get basically stuff installed into other people's devices if they're not careful enough. That's the first part. The second part is once the Trojan is installed on a device, it contacts its C2 server, command and control server, and it says, these are the apps installed on the device which I just got installed on. Let me know if you know one of them. And then the backend, it sends him a script, and he said, okay, you are working with the Lloyd's Bank, so this is a script to attack the Lloyd's app. It sends it back, and then basically what it does overlay attacks, it steals the sessions, it does the OTP. We're going to look in deep dive into more technically about other stuff that it does, and it automatically transfer the funds. This is just mimicking again what we just saw in the video. Basically, what the user sees is I am transferring some money. It sits on somebody transferring money. Like the user is doing the money transfer, the user is entering the 2FA, the user is doing all the work. Just in the back end, it just switches who it's transferring to and how much money it's transferring to. And then the user does all the checks, and then only a month later, he's like, oh, I did not mean to transfer that much to that person. I don't know who that person is at all. So that's basically the attack vectors. Now the framework. The framework this works on, and the big like, I don't know if it's breach, but what it is accessibility service. So what is accessibility service? It's basically a service in Android. It's been here since API 4. It's used to assist users with disability on Android devices. Like the accessibility services, they can run in the background, and they basically have access and they receive callbacks to anything happening on the screen. Like whenever something is happening on the screen, you get an accessibility event, and then you can do that. You can interact with it, you can read it, you can change it whenever a button, whenever a screen, and you get full feedback from what's happening in the screen. Like a good example is the Android TalkBack screen reader, where basically you can try it out. It's in all your phones. You can just install the TalkBack. And what happens with it is for the visually impaired, You can say, okay, this is the app, and then it reads out loud. This is the button. This is the hint. This is what's happening. This is what you're seeing. And then you can swipe and interact and move to the next button, move to the forward button, double tap to tap, and you can actually interact with apps that have never been seen through this without actually seeing what you're pressing on. So it works really good, but it gives a lot of control, as you can understand. And you can do a nice bunch of stuff with it. So it's important, but this is the accessibility service. That's what we're going to talk about. Let's get to the main dish. We're going to talk about writing a credential stuffing malware with accessibility service, and it's going to be simpler than what you think. Okay, it's not going to be very technical. The first part is all the code that I'm going to write here, that I'm going to show. It's code not on the victim app. Yeah, I don't know the victim app. The victim app is the victim app. It's the bank, the financial institute, whatever. Not even. I'm doing credential stuffing. It can be any app with any username, password. I'm not writing code there. I'm writing on my own malware app. Okay, so in my malware app, I'm writing a service. In my manifest, this is the main service. It's called, I'm binding to bind accessibility service. I need a permission. That's it. Okay, I'm declaring my service. The service is going to run in the background. Now, in this service, I'm going to override the on-service connected, and I'm going to say, I want to listen to any event that's happening on the screen. I just put in these flags. Yeah, include non-important fields, get all the typing data, give me all the permissions. That's it. Now, I'm listening on everything that's happening on the screen through the accessibility service. And now, okay, my service started. Somebody launched my app. My service got started. Now it's time to start playing. So, yeah, basically, I'm going to launch my target app, okay? I have the victim app. I have the home activity. I've studied it before. I know the app. I know its bundle ID. I know what's its launcher activity. I can do that even like just by querying all packages and looking at the filter intent and looking what is their launcher activities. But that's super easy. I just launch my app and I say, hey, just set components, set package, add category, start intent, start activity. That's it. I launched my victim app from my malware app. Now that I launched my victim app, what I want to do is I want to put in username and passwords. I want to start the credential stuffing attack. So I want to get into the login screen. I'm at my home screen. So I'm saying, okay, what's the easiest way to get to the login screen? I want to press on the cart. I want to press on the cart button. That's going to reach me to this login screen in this specific victim app. So I want to get to that. So I'm saying, okay, where am I? The login activity? I'm not there yet. I'm on the home screen. So that's where the accessibility node tree. Basically, it's a specific object that's related to accessibility. You get a accessibility node tree, and it's just basically a tree of all the UI elements on the screen, and you can just run DFS on it and search for whatever you want. So we're going to write a simple loop. We're going to do DFS on that tree, put it into a list just so that it's easy to iterate later. Just run DFS on that tree, put in a list. Okay, now I have a list of all the elements on the screen. Yeah, in this tree, like there's a scroll view, the buttons, a text view, and then I say, okay, let's run through that screen and find out what's the cart button. So it's called, like nobody hit it. It's called cart_btn. Okay, let's press that. Okay, so I'm iterating all the events on the screen. I'm getting to the cart button, and then I have the accessibility, perform action, click. Okay, that's it. I clicked on it. Now, the nice thing about the accessibility thing, is that you can do accessibility chaining. Like you keep pressing something, and then because you're listening on everything that's happening, you get a feedback back. So I got the home page, I got no events. Then I did launch activity, I got a window change event. I'm in control again. Now, I pressed on the home activity, I did perform action, I get a content change event. I'm in control again. Now, I'm back in control, and I'm in the login screen. So I already know how to iterate all the events in the UI. All I'm going to do is look at the cred edit text, and where the hint is equals, enter your mobile number, That's where I'm going to enter my mobile number. I'm going to go into the cred edit text where the hint is equal password, and I'm going to go and enter the password. Okay? That's it. Press on the login button, action click, I'm in. Okay? That's it. I mean, we're done. We performed credential attacking stuffing on a mobile app, on a victim app. We have no access to that app. We're just a different process, a different malware app, and like we tried it on several apps, and you can, like, the backend will not filter out if you do 5 to 7 login attempts per second. So you can run that, do 5 attempts per second, sleep, 5 attempts per second, sleep. You can attack. The backend is never gonna know that you're a malware because you're actually using the same app. You're actually using the same sessions that a real user is doing, and you're golden. Okay. So, and then like what we saw just now is an attack based on a single victim app. But as you can see, we can extrapolate that pretty easily. Like if we have a malware that's connecting to a command and control center, then you say, okay, where am I at? Query all packages, get me the apps on this phone. These are the apps. Tell me what you know. Backend sends you a response. Okay, this is that app. These are the IDs that you need to press. This is where they put in the username. This is where you put in the password. This is where you press on the button. These are the ideas. Go do it. So you write this malware once, and you can just easily adjust it to all the apps on the phones and do credential stuffing on all the apps. You have one data breach, you try it on 50 apps, 100 apps on everybody's phone, and you get the combo list, and that's it. Yeah, and you can do it. You don't have to write hundreds of malwares. You write the malware once, and you want a command and control once, and you affect a lot of devices, and you have your own botnet. What's next? It's okay. So we have this malware, and we managed to attack, and we managed to make sure how we do it. But now the hard stuff. I don't know if it's hard stuff, but how do we hide it? Because you don't want the user coming into this app, and then he sees like clicking being done on his home screen, login being done on his home screen. He's going to figure out something weird I'm doing on his phone. He's going to uninstall me, uninstall the app, close his phone, restart, stuff like that. He's going to break my flow. Any ideas? How do we hide a malware? Okay. So first part is we can use Orientation Manager, like I'm giving some ideas. So Orientation Manager, so you can listen on the Z-axis of the phone, and basically say, okay, when the phone is facing up, I'm going to close. When the phone is facing down, I can do whatever I want. Nobody's looking at the screen. So once you put the phone down on your table, no one's looking at the screen. I can go and start opening apps, sending stuff, doing credential stuffing. When you turn the flip over again, that's it. I'm closing myself. You don't know that I'm there. So that's one way to hide what we're doing. Another thing is that we need to keep the phone awake. Like we need to use the wake lock, because we're going to make sure that the timeout of the phone isn't stopping me, so that if you're having lunch for an hour, I really have an hour of trying to credential stuff, and not like the 30 minutes that your phone is clocking. So I'm going to keep feeding the wake lock and saying, keep awake, keep awake, keep awake, while I do whatever I want to do with the app. And then another thing is the overlay. So the overlay is, again, like we saw on the ATS. Basically, what we can do is we don't have to do that. We can just say, okay, let's say the user is trying by himself to log into the username and password. So while he's trying to log in, I'm just going to hold that. I'm going to delay that. Either he logs in or he doesn't, but I'm going to show an overlay. I'm going to show a spinner. You have slow network. I have 5, 10, 20, 15 seconds. I can do whatever I want in the background. Put down the overlay. You don't know what I just did. So that's another way. That's what we just saw in the ATS attack. Like it actually used the part that you were thinking that you were transferring money, and it changed stuff in the background, and you were not noticing because it put an overlay on you. And yeah. So that's basically it. Like if you infect multiple devices, that's something that can be done. It's not such a hard thing. Like Google Play keeps you safe, but a lot of people install apps outside of the Google Play, and even in Google Play, their methodology is first you upload it to the store and then you ask questions. So you can always get stuff out for like a month or a few days at a time, and then once it's delivered, okay, move it to a different bundle ID. Once you do that, every device is legit. Like nobody's gonna go and say you're running, because if you're running, if you keep if you keep it low, if you make sure that you don't do too many attacks on the same phone, on the same time, on the same IP, there's no way that the backend's going to know that you're doing something illegitimate. Like you just need to keep it under the rate. You need to understand what the WAF rules are and just keep it underneath. Nobody's going to find it on the backend. You have to make sure that you mask it. You have to make sure that what you're doing on the phone, people don't see that something's happening. And if they do, you can't be connected to it. Like you have to be a service, you have to be an app, you have to make sure that your app looks legitimate on the front end. You have, like, we used to have a joke in our company that, like, the flashlight app, you always download the flashlight app and you never know what the flashlight is doing. Like you never want the flashlight to be connecting to the internet, and you never want the flashlight to ask what the packages are, and you never want the flashlight to access all your sandbox, because it's a flashlight. It's not supposed to do all that stuff. So you need to ask questions if you see these apps that don't have permissions that you don't think they should be doing. Once you have that, you can match all the combos. You can get that, you can sell the info, and it's easy money, you know? I mean, what are we all doing here? We should be doing that. Now comes the question. I mean, me as the app developer, as the blue team, as the person developing my own business logic, my phone that has a username and password, why don't I block accessibility malware? Like, why don't I block accessibility services altogether? Like, it's such a huge tool. You can just do whatever you want with it. You can just have control on my screen without me touching it. So, well, the answer is you have to. Compliance. That's the answer. I mean, we have the European Act of Accessibility. We've seen lawsuits in the United States around it about phones and services not being complied to that. We're going to see that from 2025 happening in Europe as well. Like that's the rule. You have to make sure, like this rule says that you have to make sure that the businesses provide equal access to the services, including mobile apps, including individuals, including disabilities. The apps, they must comply with various accessibility tools like screen readers, voice commands, magnification features. It's going to be just as much money if you don't do it. Like, and of course, on top of that, you have the Google Play rules. If you get accessibility services, if you allow for the impaired, then you get ranked higher on Google Play. You get incentivized to make sure that you do give accessibility features the best features that they can get, because it is a real use case. It's not just a hacker use case. I mean, that's the whole point of it. Yeah, I gave ChatGPT my presentation and I said, write what you think about it. And he wrote that. And that's basically, the judge in the middle is the mobile developer. Like, he needs to say, okay, on the one side, I have to have my app accessible. I can't skip that. I have to have the Google Talkback work. I have to have the people that need these accessibility features use my app. I'm writing apps so that people can use them. That's why I'm writing apps. But on the other hand, I have these malwares, and I want to make sure that these malwares, they don't misuse their trust. They don't misuse these powerful tools that Android is giving me, and they don't misuse the part. And it's a lot. It's a lot for one developer to decide. And it's a fairly difficult task to make sure that on the one side, you give the real accessibility apps what they need in order to work, in order for people to use your app in an accessible way. And on the other hand, that you protect your code, you protect your backend, you protect your users, and you stop whatever you need to be stopping without interrupting. And it's a very, very thin line, and it's not an easy answer. I can tell you that. Like, we've been working on it for a long time, and we wrote a lot of code around it. Um, so yeah, before I leave time for questions, like I just want to say, yeah, I'm from AppDome. We do a lot of stuff like ATS and protecting and protecting against accessibility malware is one stuff. We are basically we're a platform that allows you to upload your mobile apps in a binary level, build them on the platform, and basically offload all your security and fraud features onto us. We make sure that it's a configuration, and once you do that, it's easy to go. I mean, our job is to do the security. Developer jobs, our customers' job is to make sure that their apps work, and that's an easy split. We take the blame for every pen test, and we take the blame for every breach because that's what we get paid for. So we have a booth, and I'm happy to answer questions about it. I'm VP of engineering. I've been there for 12 years, and it's a great place, and it's a very interesting space to be in. Yep, that's about it. Like, I left some time for questions, and I'm happy to answer. Yes.
I wonder about other platforms. Are they also vulnerable to accessibility features like iOS or?
What do you mean, data platforms?
Yeah, I mean iOS devices. Do they have the same vulnerability as Android?
Yes,
Yes.
in a sense. Like, but the attack is different. But I mean, like, everything is accessible to credential stuffing on the back end. Like, you don't need, like, you can always understand the API and then run these APIs from a computer and then attack the back end. And then if you want to hide it, then you do it from a decentralized place and from a lot of different places. It's the same idea. But we're assuming that specifically on mobile, you have a lot of anti-bot features which you can do, which you put in the mobile and you say, I know it's a user, I know it's a KYC, I know it's a know your customer. So it's harder in that sense unless you infect a real device. So on the browser, it's a bit, each platform has its own small things, but everything's vulnerable in that sense. Yes. So the question is, are IIS platforms vulnerable? Yes, question.
I was wondering because I also played with this exploit like a few years back, and I remember that for the service, in order to get the overlay, you needed some sort of permission. You need to enable like a specific permission to allow an accessibility service to display an overlay or have root access. And also, if you do that, I'm not sure if you can actually show any animating bits. I was able to only show like a static image, so not like a loader. And that was a few years back. I'm not sure what the state of that is.
Yeah, so Android did do some changes about it. Like, Android has been improving; they've been better. So since Android 12, you need to have the permissions of hide overlay windows, and you need to pass that. We were managed to do, like, you have to work, but you can do the spinner. Like, we did the spinner, we got it to work.
There's also some social engineering involved to get them to that page and approve your services. And I know you can write pretty much anything there.
Yeah.
As Google approves it.
Yeah. Also, again, one, you don't have to go through Google Play in order to install a malware. So, like you don't assume that your app was installed through Google Play. Like, it's a nice assumption, but it's not an assumption you have to make, because there are a lot of ways to install apps outside of Google Play through social engineering. And yeah, Android 12, it's a good change, the hide overlay windows. It's an important change for the Android security. The problem is, Android, you still see Android 10 phones out there. You still see Android 11s. Like, we're still supporting them. Like, we get support tickets for Android 8 and 7, like in countries. So as long as they keep moving forward, but people don't upgrade their phones, you have to solve it. Like, it's good going forward, and with time, it will be smaller and smaller and smaller. But you have to. Right now, it still is a good chunk of the market that you're still vulnerable. Yes. Well, we wrote quite a lot of code around it. Yeah, like we do some stuff. Basically, there are 3 ways to go around it. Yeah, like One of it is, say, whitelist whatever you protect, whatever you know, yeah, and say, okay, I trust 1, 2, 3, 4, 5. I want to make sure that these are 1, 2, 3, 4, 5, and the rest I don't trust. And also, you can let the user say, did you install this app? Do you know that it is accessing your stuff, and do you approve it? So awareness, that's the other thing. And the third part is understanding like the different properties of an attack. Like there's a different property of something that's reading mostly to understand and reading mostly to do user interaction, and different properties of attacking apps. Like they have different properties of what they do on the phone, how they look on the phone, what they do. So you need to profile that, understand the thin line, and do that. And in there, also, you have the ability of not providing any data in the accessibility, or providing partial data so that they can understand enough but not attack you. Like you have some stuff that you need to say, okay, this I allow, this I don't. It's a thin line. It's not a simple task. I have to say that. And it's very customizable to your app and to where you want to be. Any more questions?
For the social engineering side of actually getting the user to enable the accessibility service, I'm wondering, like, what do you see most in the wild? Would you say it's like being hid behind genuine accessibility functionality, or is it a case that they just rely on some portion of users just sort of allowing you without question?
Yeah, so I would say that most users in the world are yes, 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 approve, approve. And that's the easiest part. You open an app, it asks you a bunch of stuff, you never read it, you press it down, and even if 5% do and they don't approve, you got 95% that just like everybody's used to, like, and that's, it's a game of numbers. So even if you don't ask anything, you're in a better state than asking stuff. Just do the minimum, make sure they install it, make sure they load the app, make sure they press whatever they need to get to that flashlight, and you're golden. Yes? Okay. So thank you very much.